Today we are going to discuss about diode clipping circuits. Diode clipping circuits are also known as limiters. Clipping circuits are nonlinear wave shaping circuit which are useful to clip off or cut off the positive or negative portion of an input signal. It can also be used to slice off an input waveform between two voltage levels. Using a double clipper, we can form a moderately square waveform can be generated from a sine wave. The diode clippers can be classified as a series. Broad classification is series clipper and shunt clippers. In our discussion, we are discussing about shunt clippers. Clipping circuit are basically classified into positive clipping, negative clipping, biased clipping, and double clipping. Double clipper with the same voltage level, that is known as slicer circuit. The broad classification of clippers are shunt clippers and series clippers. According to the voltage source applied, that is according to biasing, clippers are again classified into unbiased clippers and biased clippers. Biased clippers means if you are applying any battery sources, that type of clippers, we name it as biased clippers. Sometimes it is desired to remove a small portion of a positive or negative half cycle of the signal voltage. Biased clippers are employed for this purpose. According to level of clipping, we already discussed that the broad classification of shunt clipping circuits are positive clippers, negative clippers, biased clippers, that is combination clippers is also known as slicer. What do you mean by a positive clipper? Positive clipper is a clipper which removes the positive half cycle of the input voltage, while the negative clipper which removes the negative half cycle of the input voltage. Sometimes it is desired to remove small portion of positive or negative half cycle of the signal voltage. Biased clippers are employed for removing small portion of either at the positive half cycle or at the negative half cycle. If the entire positive half cycle is clipped off, means that type of clipper is known as positive clipper. If the entire negative half cycle is removed, means that type of clipper is known as negative clipper. Next, we will discuss what you mean by a transfer characteristics of a clipping circuit or wave shaping circuit. Transfer characteristics is basically the graph between the input and output. In the x-axis, we are plotting the input voltage, and in the y-axis, we are plotting the output voltage. For the above figure, the input voltage is the sinusoidal signal, that is varying signal, and the output is a positive clipped waveform. Positive half portion of the signal is removed or sliced. When a sinusoidal signal passes through a positive clipping circuit, the output waveform will appear like this. How we can plot the transfer characteristics for the given signal? The input axis, that is in the x-axis, positive direction, input voltage varies from 0, 0.1, 0.2, 0.3, 0.7. At that time, output voltage also varies up to 0.7. The variation is linear to the input wave. After the cut-in voltage is reached, the output remains when the input varies to the maximum peak, output remains at 0.7 volt. During the negative half cycle, when the input varies at the negative axis, output also varies linearly with the input signal. The same replica of the negative half cycle is plotted in the transfer characteristics of the positive clipper circuit. This is the basic circuit diagram of a positive clipper clipping at 0 volt. In this, a diode is connected parallel to the input signal and the output is taken across the diode, that is the parallel. So the type of clipper is known as shunt clipper. In the case of positive clipper, positive half cycle of the input signal is removed or sliced. The negative half cycle of the input appears as such. The transfer characteristics of the positive half cycle is as shown in the figure. This is the circuit diagram of a negative clipper. We already know the classification of clipper. In positive clipper, the diode's positive part is connected at the output side. Input is applied across the resistor and the ground. Is the circuit of positive clipper. Circuit diagram of positive clipper is as shown in the figure. In the positive clipper, we are applying a sinusoidal signal at the input side. At the output is the input signal applied across resistor and ground. We are expecting if the diode is ideal, we are expecting the output, that is the positive part is completely removed, only the negative part will appear at the output. This type of waveform we will observe under the condition that if the diode is ideal. Normally, the diode operates under forward biased condition. That is, if the cut-in voltage of the VI, if we check the VI characteristics of diode conducts when the cut-in voltage of the diode reaches 0.7 volt. Until that, there is no current flow in the diode. This is the diode's characteristics, VI characteristics. If we are using a silicon diode, means the cut-in voltage is 0.7 volt. After that, the voltage current, when the diode's potential becomes 0.7 volt, only then the current flows exponentially. So if you are considering the practical scenario, means the waveform looks like, if you are using a practical diode, means you will get the waveform like this. Under 0 up to 0.7, there is no diode is open circuited. There is no current flow across the diode. Until it reaches the cut-in voltage, it becomes short circuited and no output across this is cut-in voltage of the diode, that is 0.7 volt. When the negative half cycle of the input reaches, means the diode becomes reverse biased and it is open circuited. So the entire waveform appears at the output side. Positive half cycle, only the cut-in voltage remains. Negative half cycle, entire waveform appears at the output. This is the working of positive clipper. If you are designing a negative clipper, means the diode's direction will change. Diode is connected negative part in the upper side. The case of negative clipper. The only change is the diode's direction is reversed in the case of negative clipper. So, two cases of clipper circuit, that is the broad classification of shunt clipper, that is positive clipper and negative clipper. In the case of positive clipper, positive half cycle is clipped off. In the case of negative clipper, for entire waveform positive half cycle will appear at the output, and the negative half cycle, only the cut-in voltage will remain at the output. Positive half cycle entire waveform will appear at the output. This is the basic classification. Next, what will we add? The battery supply, that is the biased clipper. In the case of both positive and negative and positive clipper, if you are adding battery source, means that is, if you are applying any battery source, means that type of clipper is called as, if you are adding a battery source, means that type of clipper is called as biased clipper. Biased clipper. If you are adding a positive battery, means this figure is negative clipper with positive voltage. For example, if you are applying 2 volt positive volt, means this is a negative clipper with positive 2 volt. If the battery terminal is reversed, means the given circuit is a negative clipper with minus 2 volt battery supply. We will discuss all the type basic classification of clipper circuit. Already we discussed about basic positive clipper and negative clipper. In the case of positive clipper, positive half cycle of the waveform is removed or limited. In the negative clipper circuit, negative half cycle of the waveform is clipped off or removed. In the case of positive clipper with biasing potential 3 volt, means what will happen? If you are applying positive half cycle of the input voltage, the diode, when the cut-in voltage of the diode reaches 0.7 volt, the diode will conduct, and the terminal potential across diode and battery supply will become series connection. So it will add, that is plus 0.6, the cut-in voltage of the diode and the battery supply. The total output voltage will appear at 3.6 volt. Negative half cycle, what will happen? The diode becomes reverse biased, so it will become open circuit. So output is taken across resistor and ground. So output, the entire negative half cycle will appear at the output. The transfer characteristics of a positive clipper with a positive biasing voltage is shown in figure. Likewise, when the battery supply is reversed, means we will get a positive clipper with the negative biasing voltage. What will happen to the output voltage? The terminal potential we can add, that is 0.6 plus minus 3. 0.6 plus minus 3 means the effective voltage at the output terminal. 0.6 plus minus 3 means the effective voltage at the output terminal will become minus 2.4. If understand, similar cases applied to negative clipper also. Negative clipping, when the biasing potentials applied is plus 3 volt means the battery terminal, the diode potential here becomes, this is the cathode of the diode and this is the anode of the diode. So the voltage across diode is minus 0.6. The battery potential here it is plus 3. So the effective voltage at the output becomes minus 0.6 plus 3 equal to plus 2.4. So the output voltage is remaining negative half portion completely clipped off. Only the output above 2.4 will appear at the output terminal. In the same scenario, when we apply negative clipper with a negative biasing, so the effective voltage will become minus 0.6 minus 3, that is the effective voltage becomes minus 3.6 voltage. Only here the terminal potentials are calculated when two battery sources are connected in series, means the effective voltage is the sum of the voltages applied in series. Here minus 0.6 plus minus 3, the effective voltage at the output terminal become minus 3.6. Likewise, the combination of positive clipper and negative clipper, we can call it as a double clipper. Double clipper with biasing potential plus 3 volt and minus 3 volt. This individually we can call it as a positive clipper, and the second part we can call it as a negative clipper. When we apply sinusoidal signal, when the positive half cycle comes, the diode D1 conducts and D2 is reverse biased. D2 is open. So the output is taken across resistor, this point and ground. So effective voltage at the output is 0.6 plus 3, that is 3.6 volt. And during the negative half cycle, what will happen? The reverse action takes place. That is, the diode D1 is reverse biased and D2 is forward biased. So the effective voltage, this will act as a, first part will act as a open circuit. Second part will act as a closed circuit. So the effective voltage at the output becomes, this is minus 0.6 minus 3. That is minus 3.6 volt. In the case of double clipper, if you are applying the biasing potential, that is the both the positive half cycle and negative half cycle battery supplies are connected positive, means we can get a slicer at the first quadrant. Or we apply, if we are reversing the battery sources, means we are getting the output waveform sliced both at the negative. So the we can get the transfer characteristics at the negative axis. In the case of slicer, we are applying a positive half cycle, and during the positive half cycle of the input signal, diode D2 conducts and D1 is reverse biased, and the effective voltage at the output becomes, during the positive half cycle, the effective voltage at the output becomes 5.6 voltage. Clear? And during the negative half cycle, what will happen? Diode D2 is reverse biased, so it is off. That is, this path is open, and diode D1 conducts. D1 conducts means the effective voltage at the output is minus 0.6 plus 3, that is 2.4. So both positively we are varying the signal means positive half cycle and negative half cycle. The portion of positive and negative half cycle is sliced or cut at the positive voltage only. That is, the output is sliced at positive voltage. In the similar case, we can get at the, if we are applying the battery terminal both negative. So entire positive half cycle portion will cut at minus 2.4 volt and negative half cycle will cut at minus 5 volt. Here in this case, during the positive half cycle, diode D1 conducts and the effective voltage across this terminal is minus 2.4. So during the negative half cycle, diode D2 conducts and the effective voltage becomes minus 0.6 minus 5, that is minus 5.6 voltage.